Okay, hi guys. So in this lecture, we'll be going to talk about Pinacolone rearrangement. So let me put down the heading first. Pinacolone rearrangement. Okay. So in this, we are going to talk about. Let's with an example. Let me explain this. So before that, let me write down some facts that CO bond energy is total 725 kilojoule per mole, and out of that, pi bonds energy is 375 kilojoule per mole. Okay, so after this fact explained, let's explain what's Pinacolone rearrangement. So suppose I have something like this. I have this product or this organic compound, and we are passing it in a acidic medium, and we are providing heat. So we find this as the major product of this reaction. Let's talk about the mechanism of this reaction then. So how this happens is we have this compound, and OH. Similarly, I have a symmetrical compound. So what happens is this attacks on H plus to form positive charge on itself, and it withdraws itself. So I'm directly showing the second step with the carbocation formation on this carbon. Okay, now what happens is we already know that IIT cation is very stable. What I mean by IIT cation is positive charge neighboring to lone pair of oxygen atom. Okay, so the positive charge will try to rearrange itself so that this carbon actually has a positive charge for the formation of IIT cation. Okay, so what happens is CH3 minus shift happens, and due to which we get something like this. And okay, now what happens is obviously this is our IIT cation, most stable cation to be formed in intermediary reactions, which actually drive forward the reaction of various mechanisms. Write it clearly. Okay, so now what happens is after it has donated its lone pair to this carbon atom, we'll get something like this O positive and H with this as the product. Obviously H plus will then be recouped back into the reaction because because O oxygen atom would actually withdraw its electron from the O and H bond. So what we'll get is something like this. So this would be our product. Okay, and this is actually known as Pinacolone. Okay, and the reacting compound was known as Pinacole. Okay, hence this is called Pinacolone rearrangement. Okay, so now let's practice some more examples on the same. Suppose we have, now let's start the example practice. Suppose we have something like this. So what would be the product after the pass? This is in an acidic medium. This is called Pinacole. Why? Because of the presence of 2 OH on the adjacent carbon atoms. Okay, so what will happen is we'll get a positive charge here. Okay, so this H plus can either be attacked by this oxygen atom and in this oxygen atom. So on which oxygen atom we should attack our H plus, which would form a main or a more stable product, intermediate I mean. So if I just react on this oxygen atom, then this will actually withdrawing its bond from the carbon atom, and this carbon atom would be getting a positive charge. And in this case, similarly, this oxygen atom would be attacking on H plus, and the same oxygen atom would be withdrawing its bond electron from carbon atom. So this carbon atom would be getting a positive charge, and in this case, this carbon atom would be more stable. Why? Because of plus M effects. And in this case, only hyperconjugating or plus H effects are there because of these two CH3 groups. Hence, positive charge carbocation would be formed on this carbon. So we will get as intermediate something like this. Okay. Now it will undergo rearrangement via CH3 minus shift. Not to mention there is a OH also present. Okay. Due to the formation of our IIT cation, it would be more stable. Hence, you would be getting something like this, and positive charge on C, CH3 and OH. Now again the lone pairs will be involved in forming a pi bond between C and O atom, and this hydrogen would hence be removed. Okay, so we would get something like rather it should be something like this. The OH bond, oxygen would be withdrawing its electron from the hydrogen atom. Okay, so we'd get something like this as our Pinacolone. This would be the product of this reaction. Okay, let's take a look at another example. Here we have something like this compound. Obviously we are talking about Pinacolone. It would be a Pinacole compound only. Why? Because we are discussing Pinacolone rearrangement. Okay, so I will be giving directly Pinacole only. So as you can guess, so H plus and heat. So what would be the major compound? Obviously now you can actually compare that on actually which carbon atom the positive charge intermediate, the first intermediate which would be formed, which would be more stable, either this or this. From now we have done so much practice that only this would be more stable, and I may not repeat the reason why, because of more plus H effect. Okay, now again what we would be having, H minus shift. Okay, so what would we get? CH3 and positive charge here with the OH present here. Again the same type of thing again repeats itself in formation of Pinacolone. So we would have something like aldehyde formed here due to rearrangement, Pinacolone. Okay, this would be the major product formed here. Okay, let's look at another example. More practice, more good. More the less chances of performing mistake in the final exam. इसलिए that I insist more on practice. Now we have something like this. I'm sorry, that's oxygen carbon atom, pH and pH. Again we provide this acidic medium to Pinacole. What would happen? Formation of Pinacolone is ought to happen, but how will it happen? Where will be positive charge carbocation be more stable? Obviously on this carbon. Why? Because of presence of 2 plus M groups, phenyl rings. Okay, so what would be the intermediate look like? Intermediate would be something like this, with 2 pH here and water molecule released. Okay, now what will happen is ring expansion will take place, in which this bond will get, this carbon atom will get a positive charge, and this will involve itself in ring formation. Okay, so a ring is formed with 2 pH groups and positive charge here and OH here. Next what will happen? Formation of aldehyde at this carbon ketone at this carbon atom, and finally this is what we call as Pinacolone. Okay, so this is the product. Okay, next let us talk about another example. Here we have something like this. something like this, and OH attached both at both positions. Okay, and we pass it in acidic medium and we heat it. Okay, so what would be the product formed? You can remove OH from either of the two carbons because these are identical. So in the intermediate we will get something like positive charge here and OH here. So again it's a case of ring expansion. So again what will happen is this bond will be breaking up. Okay, let me write the OH above so that I can show you more clearly. This is OH group, so this bond will be breaking up and joining with this carbon atom. So we would be getting something like, at this carbon atom we will be getting cyclohexane ring. Okay, and here we'll be getting a pentane ring as it is. Cyclopentane ring as it is. So on this carbon will be attached a cyclopentane ring, and on the adjacent carbon we'll be having positive charge attached with OH. Now what we'll be getting? Again double bond O and O. This will be the final compound. Okay, I just redraw this cyclopentane ring over here, but I think it is clear that what I'm trying to do. Okay, so just for the sake of clarity, I'm just writing numbering the carbon 1, 2 and 3. So what happens is the third carbon is attached to the first carbon. So between second and third carbon, this was the second carbon, this is the third carbon, and first carbon is this one only. Okay, so the bond actually broke up and attached to this carbon. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing some more of Pinacolone rearrangement, and till then, good luck and goodbye.